Hello, everybody, and welcome to another exciting episode of the Adventures of DevOps podcast. I am your host, Jonathan Hall, and here in my virtual studio with me is Jillian.
Hello.
Hi, Jillian. And joining us today, our special guest is Mirco Herring. Welcome, Mirco.
Thanks for having me.
Would you tell us a little bit about yourself, what you do, maybe how you know anything about DevOps?
Yeah, absolutely. So I'm the global DevOps lead for Accenture. For the last 13 years or so, I've been working in this space, really helping complex organizations try to make the best use out of DevOps. So I work a lot with what I call heritage applications like mainframe or Java applications, Salesforce, Oracle, you name it. Basically in an environment where there's lots of interesting technologies to solve.
Interesting. So I think maybe a good place to start then would be to hear your description or definition, if you will, of what DevOps is, because it's a fuzzy word. Everybody means something different by it. When you talk about DevOps, what does that mean to you?
Yeah, so for me, DevOps is really an umbrella term. And what I mean by that is there's a lot of different practices that fit within this. And they're all for the purpose of building IT solutions in a better way, faster, more secure, and ultimately make it easier for developers to solve the business problems. I'm not too fussed with these specific buzzwords, to be honest. Like every couple of months you get a new DevSecOps, MLOps, AIOps, SRE, platform engineering, and to me it's all just they're kind of facets on a prism of what we're trying to do. But at the end of the day, we're all here to improve the overall way that we develop solutions.
Exactly right.
I like that way of thinking about it. It's more about thinking of the process rather than, tightly defining the thing itself.
Yeah, and I was just like the last couple of keynotes I did at DevOps Days, like there's different titles, but it's basically DevOps is dead, long live DevOps. And kind of making exactly this argument.
I like that. Yeah, we actually had an interview on this show a few months ago, I think, with somebody. I don't know if they were credited for creating the DevOps is dead meme, but they certainly perpetrated it, and they were kind of feeling sorry for it. Like people took it entirely the wrong way. So yeah, I like that. DevOps is dead, long live DevOps. There we go. So I don't know if you want to talk about a few stories, maybe specific client stories that you could tell about, or a technical challenge that you face. How do you like to address this topic?
Yeah. So let me start with the way that I think about it, because I don't know whether it's unique, but it's certainly the thing that I've learned over time, and I've come through. In 13 years, you come through a couple of waves of this, right? I was an engineer initially, and I certainly thought that just having a better technical solution or better tools or whatever would give you the answer. And I've matured out of that, understanding now that it's a lot more about, bringing, the capabilities, so the practice like continuous delivery or continuous integration together with the organization. So you can think about the kind of organizational structure of, having all these kind of siloed teams to more full stack teams, and then bringing that together with the architecture of your technology. Because from my experience, architecture is this kind of dirty secret. If you have a big monolithic mainframe, then there's only so much you can do with DevOps. And so you have to you have to basically address all three dimensions. You need to uplift your capabilities. You need to arrange your organization the way that is most optimized. And then you need to evolve the architecture to something that you can ideally support with that.
Mm-hmm.
Are you saying the engineers should maybe talk to each other?
Would be a good start.
Yeah.
And I'm a big fan of full stack teams instead of this idea of these unicorn full stack engineers. Right? So I think you need to have the capabilities in your team, but I don't necessarily believe that every engineer is going to be the superstar.
Right.
I definitely agree with that. There's just too many things for anybody to be a superstar in anything anymore, I think.
But and I think full stack engineers works when you're a startup in a garage and there's like 5 of you because you have no choice. Right? But if you get to big organizations, there's thousands and thousands of developers, and you can just that's just never going to work.
Mm-hmm. So you made an interesting point about the architecture. The technical architecture is important for DevOps. Are there architectures that you think are fundamentally incompatible with the DevOps approach? And if so, why?
See, I think you can use DevOps ideas for everything.
Mm-hmm.
Now, I think there's a concept that I like to use with my clients. It's called transaction cost. It comes kind of from Reinertsen and from product management and so forth. But the idea is that if you build a solution, then for that to go live, to become productive, there's a transaction cost. And the transaction cost describes how quickly you can get something done. If you have a big mainframe or big package software, then the transaction cost is high because you need to get all these changes together into one bundle. You need to kind of compile it or build it. You need to deploy it, and you might have to stop pretty much the whole organization to do that deployment. That's a massive transaction cost. If you have a microservice and you can deploy that at any point in time, and you have multiple versions live in production, then the transaction cost is not zero, but it can get very close to zero. So the goal of all we're doing in DevOps is to reduce the transaction cost. Now, the transaction cost on a microservice might be from 5 minutes to 4 minutes. The transaction cost on a big monolithic mainframe might be from 3 months down to 2.5 months. Right? And the principles are the same. You're looking for ways of improving the way that you validate quality, testing, test automation, code scans, whatever that is, or it's the actual deployment mechanism, or it's the validation afterwards. Right? So you have to kind of look for each technology, what is the bottleneck in that end-to-end process, and then improve that. Right? You're looking at a series of constraints, right? You're looking for the one thing that is holding this specific stack back. And so to me, it's, we have this tool belt, and we need to figure out what the contextual problem is, and then we use our tool belt to address that specific bottleneck.
So what are some interesting problems you've been tasked with solving or come up with?
I guess. We can cover let's cover kind of three different things, and there kind of go down kind of my favorite path of craziness, I guess. So if you take something like the Siebel application, right? It's the big package, and one of the problems to solve there was like if you have multiple teams working on a big monolithic package, is how do you manage code? Because at the end of the day, if you want to be at all independent in your individual teams, you need to find a way to share code. And so one thing that we had to then look at is, and what Siebel does, and there's other package software that does it as well, is whenever I check in code, it basically creates a bunch of metadata that gets stored. At what point did I change this field or this specific data set? And what that means is when you compare code, you have only conflicts because this kind of metadata always differs. And so the problem that we had to solve is like, how do we identify just the code that matters? And so we had to create basically it's a comparison tool that ignores all the metadata that doesn't carry payload and only looks for the configuration that matters. And then you had to build this into your kind of IDE stack so that you can have the individual developers being able to use this and then still combine afterwards a fully working product. Right. And so that's really kind of you dealing with the kind of core architecture of an application that was not built with DevOps ideas in mind. And we had to kind of solve that for them. Salesforce was very similar for a long time, and they have brought out DX just a little while ago to address some of that. So that's one of the things where you just kind of really get to the core architecture of it. And I find this fun as an engineer. I'm not sure whether that's the most traditional way of looking at it, but I find it fun to just look under the hood and figure out how we can play around with it. That's one type of problem. Then you have the type of problem that is purely organizational, right? So how do we look at large organizations that might have big testing centers or very separated practices and reshape them? Yeah, and how do we bring organizations together? And really, my answer to that at the moment is to do value stream mapping, right? To bring all these people together in a room, to Julian's point, like get them to actually talk to each other, to start understanding, wait a second, like what is your job in here? And how can I actually make your job easier by providing perhaps my content in a slightly different way or with different metadata or in a different format? And really start to just see how once you bring people together in an open-minded way and with some visual facilitation, that they can actually start addressing kind of organizational problems. And then the third one that I find fascinating is, so how do we make it stick? Because I've been in several organizations, certainly in the earlier iterations, where you go in because you want to do a DevOps transformation. And, the executives are getting really excited about that. And you're going to do this. And then the CIO gets replaced and they have a different interest. And they just stop because no one can explain why we did this. Right? So, show me where the benefit is. And, you saw this with Agile as well, where you say, oh, but we have more Agile teams. So what? What exactly? We have continuous delivery. Okay, how does it help? You know what I mean? So it's so you kind of see, if you want to be successful in an organization, you have to kind of address all these three different problems, right? You have to do the kind of engineering. You need to look at kind of the process and the human system, and then you also need to address the kind of the executives and the business case and the value and the why are we investing in this?
Well, those are really good examples. I always think it's really important for engineers to learn how to speak a little bit less in tech speak, and then learn how to translate that back to, and I suppose we could say the business case, but what is the problem that you're trying to solve, and how does it relate to that? Just like you were saying, we have Agile. How does the person who's not in the tech speak know what that means, or know why that benefits them, or anything of that nature? So it's always really important to bring these concepts back.
And there's no one walking around kind of giving you the certificate at the end saying, you're Agile, you're done here. And this is actually one of the really fundamental problems, I think. It's what we're doing now is a transformation that has no end.
Right.
And I think that's really hard for people to get their head around, because it's not like there's no end state, right? It's not like as is to be and we're just going to make our way across this chasm. It's like every week there's a new technology. Now we need to deal with, how do we deal with computer generated code more, and how do we control that, and how do we do quality assure that, and how we deal with CIP considerations, and in 3 or 6 months time we have the next thing that we need to start solving for.
I think that's one of the reasons it's one of the reasons that so-called Agile or DevOps transformations fail so often, is because they really do never end, and it's almost a misnomer to call it a transformation. You might think of it a transformation of mindset. We were in the mindset of things go this way, and now we're in the mindset of things are never the same, they're always improving. But you never reach that end goal. There's no finish line, right? You never okay, now we're Agile, we can stop doing those things now, we can stop improving our DevOps. I had somebody ask me once on an interview a few years ago, I think, so Jonathan, if a company does all the right things, are they can they say they're doing DevOps now and then stop improving? I was like, well, you could say you're doing DevOps at the moment, but once you stop improving, then if you're doing the exact same things a year later, no, you're not doing DevOps. If you aren't improving your processes every day, every week, you're not doing DevOps or Agile the way it's intended to be.
Yeah, I use this analogy with my clients, where it's kind of the equivalent if you are a slightly overweight, middle-aged white male, and you go to the doctor and they say you have high blood pressure and you should really lose some weight. And what I'm looking for is for the doctor to give me this pill that I need to take once, or the cabbage diet for 3 weeks. Right. And what he's going to tell me is, Mr. Herring, you need to work out more and you need to eat healthier, and you will need to do this for the rest of your life.
Right.
And I think that's exactly the same, right? The kind of magic pill or the cabbage diet is the SRE playbook and the latest CD technology, right? That's not going to solve your problem. It's using all that stuff to really become a better organization on an ongoing basis.
Exactly.
So DevOps is the vegetables of the tech world. I kind of like that, actually, as an analogy. We're just running around being like, you eat your vegetables, put down that ice cream, put it down.
Your DevOps.
Come on, here's some broccoli, pretend they're tiny trees under your dinosaur, go nuts.
DevOps is good for you.
Exactly.
I can tell you that my 6-year-old actually puts on the pizza spinach and broccoli, which I find terribly weird. But
if it gets them to eat it, why not, right?
Yeah. It's not the pepperoni. It's spinach and broccoli on a pizza. Okay.
My kids have always been okay with broccoli because you can pretend you're a dinosaur with their little trees and eating them. And for reasons, that's always been. Except for my 12-year-old, she's too cool for that now. But back in the day, it worked, and she still likes broccoli, so we're good.
Well done.
So I have a couple questions, and one of them is probably going to be a stumper, but I hope you have an answer because I've been looking for one for a while. But first, you talked about bottlenecks. How do you how do you identify bottlenecks when you're working with a company? What's the process you use to identify the bottlenecks to improve?
Yeah, and look, as I said, like I think my magic tool is the value stream mapping. It's just what I found the most useful thing, which is you're really kind of mapping out the IT process from idea to production, and the specific steps. And then bottlenecks for me have a couple of different flavors, because bottlenecks can be things that take a long time. Like standing up an environment, getting access to an environment, creating test data, whatever that is. So it's a kind of a duration bottleneck. I think the second type is a quality bottleneck, where we find too many defects, the environments are too unstable, the deployments are not reliable enough. Like you have a quality bottleneck. And then the third one is backflow, where you have basically things that you thought are solved, but they're coming back, and that might be just clarifications, it might be incidents, and so it's those kind of different bottlenecks that you can identify. And usually, if I show you the value stream maps I've done, it's kind of, imagine you have kind of green post-it notes for processes and red post-it notes for problems. Mm-hmm. They usually have nearly as many red post-it notes as green post-it notes. Right? So it's a target-rich environment usually in big organizations. And then it becomes, which ones can be addressed because they're within our remit, and it's not like, I need a CEO to make changes, or we need to change the budgeting process, or those kind of things, and still have an impact. So you kind of do like, impact versus how difficult it is on a two-dimensional graph, and then you figure out which ones you can actually address with the team that you have. How
do you know if you've addressed a bottleneck? How do you know if you're making progress? And let me paint the picture a little bit further, because sometimes it's obvious. Deploys were taking 6 weeks, now they're down to a day. That's progress, right? That's pretty obvious. But sometimes you have a process change that maybe has a long lead time, or it requires people to learn something new, and there's a learning curve to it. So maybe an example is we're going to throw away Jira and start using stickies or something like that. And there's a lot of pushback because, this feels harder, or there's more work to be, I don't like writing, or whatever imagine a scenario where you're getting pushback. How do you know if that pushback is legitimate and that the new process is worse versus, because of the short-term pain? The pushback usually comes from some short-term pain. Is that short-term pain endemic of something bigger, or do you need to push through that short-term pain with the faith that something better is coming through? How do you make that call?
Yeah, and this is where you would like to get the magic answer, which I won't be able to give you.
Of course, yes. Everyone wants this answer.
But I think I describe a lot of this as, I'm a man of terrible analogies, but I describe this as kind of breathing in and breathing out, because I think there's these things that you just try and experiment with, and you're going to allow this to go for a while while you're kind of breathing in, and you just let it run for a little bit. But if after 3 months or 6 months or whatever you agree as a period, it's not, if it's the same as before, all right, then let's stick with it. Like there's no reason to move back. If it's worse, still after that period of time, then we need to try something different. Might be going back, or might be, yet a third option. But if it's better, then we now agree that this is now our new standard. And that applies for process changes that you described, but it also applies for, hey, like we really hate Git, we want to go back to Bitbucket or whatever, right?
Sure, yeah.
Okay, be my guest. I'm letting this team go for a little bit. But if they can't justify after 3 months why this thing is better or not, but it has extra cost for us because, different licensing or whatever else, then you have to come back to the fold. So a lot of this is, you can describe it as a pendulum swinging, you can explaining it as breathing in and breathing out. But I think you just have to have some of that, because not everything is linear in transformations.
Right. Yeah, that's good insight. I like the way you put a time cap on it too. You said 6 months, and sometimes that's appropriate. Sometimes you might just need a few weeks. But yeah, I think putting I like the phrase, let's try an experiment. When you get pushback, well, let's try it for 2 weeks. Let's try it for a month, and then we'll come back and reevaluate.
That would be, and I stay with my analogy of the guy who's trying to get fit, right? That's like doing your first workout. The next morning you wake up and you're aching. And you're like, I'm not going to do that again. It's like, no. You have to stack for a little bit. We'll see that it's actually getting better.
Excellent analogy. Yeah. I hate running. I hate work. I mean, literally, I hate running. I don't mind some workouts, but I hate running. But yeah, if I were to judge my success based on the morning after, especially the first week, I would never do exercise.
It is like that, and a lot of this stuff. I mean, there's no, if there would be, and this is now that I'm a parent, it's true for parenting, right? If there would be a right answer, everyone would tell you the right answer. Given that there's like 50 different ways that people tell you how to do it, that means there is no one answer, which means you need to find the one that works with your child or with your team.
Yeah, kids are the ultimate example of a science experiment. They really are. Yeah, I've also found when working with a big group of people, that's often a good way to get some kind of buy-in is, don't let anybody be too, including yourself, be too kind of emotionally invested in like what you think the outcome is going to be, and instead kind of frame everything as like, all right, this is sort of the hypothesis that we're testing. And we think, I think using a time frame is a really great example. We're going to test this out using this time frame, and this is the outcome that we're hoping to get to say if this was, like if this was successful or not. Or maybe have some other kind of metrics in terms of, like what's successful and what's not. And I think you can get people on board with something like that pretty swiftly.
And I'm a huge fan of getting metrics. It's just some of this stuff is hard. Like, what feels easier, right? I mean, how do you put a metric around this? But other things are very metrics driven, and a lot of the engineering processes are pretty aligned to that. Where you can measure deployment times, you can measure defect rates. There's a whole bunch of stuff that you can measure. But for some of the stuff, you just need to stick with it, and then after a while, just says, hey guys, like, what do you think? Is it now more painful to go back? Is it worth sticking where we are?
So you said you concentrate on kind of what sounds to me like sort of an enterprise software, maybe stack, like Salesforce and I don't remember what were the other ones that you mentioned. But have you found any kind of patterns or just anything interesting you found specifically with working with these types of software? Because I know I don't work with any of those, so I'm just interested in your experience. Much more on like the startup side of things rather than the enterprise, and it's all a bit like what's happening over there.
Yeah, what I find amazing, and this is again one of those things that I've only come to realize over the last couple of years. I find this, by the way, amazing how I have completely believed that I need to disagree with myself once in a while. Like I very much disagree with myself from 5 years ago. I'm probably going to disagree with my today in a year's time, right?
Mm-hmm.
I used to think that there's technology-specific solutions and that these technologies are very specific. And now I'm at the point where, like, actually in the overall scheme of things, when you look at the build process, the deployment process, the testing process, etc., they are pretty similar. Like the individual components underneath are different. But there's an overarching process that we can align. And I think that's becoming a lot more important, certainly in large organizations, than the optimization of the individual team. I take a really simple example from my early days of Agile, where lots of organizations, the teams can choose their own tools. Brilliant idea, up to the point that you realize that now these people can't even speak to each other anymore, right? Your Jira dependencies against the Azure DevOps, against the Rally, against the whatever, like it just doesn't work. And we sometimes forget that this is an overall system, and that means we need to really optimize the overall system rather than the individual components. And that means we need to have similar language. We need to make sure that our mainframe colleagues can speak to the same people as our, Google data lake people. And if we don't facilitate that, then we can't expect the organization to work well. So for me, that is one of those things that I've spent a lot of time with now to try to align these worlds and get people to understand that the overall process of you still build an application. Yes, it's completely different for your Salesforce application to a Java custom build, but you're still building it somehow. It might just be that it's abstracted away from you, and you're still deploying it, and you're still dealing with an environment, even if it's a SaaS product. There's still an environment somewhere. There's still a data consistency somewhere that you're dealing with, and so it's really getting that kind of commonality and highlighting that over the difference that I spend a lot of my energy on, and that I think is helping organizations to improve the whole thing, and not just have the runaway cool team and then the older guys falling behind.
Mm-hmm. It's really easy, isn't it, for techs, whether it's SREs or developers or whatever, anybody in the tech field to get caught up with the shiny new tools and fall in love with their tooling, but from a business standpoint, that's almost irrelevant. It's not completely irrelevant. I mean, it's kind of like if you let's say you own a fleet of rental cars, and you hire some mechanics to work on those cars. They may care about the exact fuel injectors you use and the exact brake pads and whatever, or maybe they want the new greatest regenerative braking technology, whatever they might get excited about. They can care about that, and that's not unimportant. But at the level of managing a fleet of vehicles, you don't care what kind of brakes are on those vehicles, as long as they can stop when they're supposed to.
Yeah.
And you want them all to be the same because you don't want to have to keep stock of 800 different types of brakes.
Yeah. And look at organizations, right? So big organizations, when you look at the tools they use to run their IT, it is as complex as the business applications they run, right? Because they have dozens and dozens of tools, right? Yeah. And arguably, I'm with you, right? There are some tools that are better than others, but I've done DevOps automation with Control M, right? I mean, that kind of worked, right? Mm-hmm. And all these people that are spending months trying to decide whether they go with tool X or tool Y, I think they're really missing the point.
Definitely, yeah.
I wonder how much of that is going to kind of start to go away a little bit with with just the huge advents that we're seeing in AI and in these kind of, I'm not exactly sure what they're called, these sort of transformative tools where you're like, you have Python, but then you get like this sort of schema that then can be translated into any of the other languages, right? Like a lot of the web APIs have this. Or now, for example, I've been getting back into C++ lately because I have, the GitHub Copilot and the AI tools in my IDE, and they can very easily autocomplete for me. And so I care less about the fact that I'm like, I have to remember all these things with C++ that I don't really feel like remembering because the IDE remembers it for me. And so I wonder how much this is going to kind of influence maybe some of these teams that are on one side of the fence or the other, where they're very, very constrained with their tool choice, being very, very open. And if it's going to make the people who are very, constrained kind of maybe move towards maybe we can be more open with our tool choice because it just doesn't matter as much anymore. Have you seen any of that happen?
I still have like this inherent hope. It never really materialized, but that we get to a point that we get these tools to work together. Right, the kind of the ESB for tech tools, like we just never got there, and it's kind of frustrating because each tool ended up becoming its own walled garden. And I'm the one who orchestrates everything, but don't you dare try to orchestrate me. And that's just like I think an anti-pattern. You can see this kind of this pendulum swing, right? We have all these new tools coming up, and then they all consolidate because one vendor gobbles up a whole bunch of them to build this end-to-end solution. And I find this fascinating when you go to the individual kind of tooling conferences. You can totally see that pattern, right?
I kind of wonder if, in some ways we've standardized. I mean, like Docker is a pretty universal abstraction layer that virtually everything uses. Not literally everything. I mean, if you're using Heroku or something, maybe you're not always using Docker. But almost all the big tools can use Docker. So there's one layer of abstraction that's pretty common. Terraform doesn't really it sort of gives you a layer of abstraction on top of everything, but it's not really abstraction. It's just a common like file syntax that works with everything. So it's not it's not like you can just drop in S3 in place of a Google bucket or vice versa, but it's kind of an abstraction. On the other hand, if you want to, and then things like Kubernetes give you an abstraction mostly. If you could more or less take your Kubernetes payload from one cloud to another, with some tweaks. I mean, depending on exactly what you're doing. But I think in a lot of ways it's similar to going back to the car analogy I just made. If you're driving an American car versus a European car or a Japanese car, they all work more or less the same. But you have to learn different things. You have to get metric tools or imperial tools. But, for the most part, the principles are the same. I mean, nobody would say, I can fix a Japanese car easily, but I have no idea how to fix an American car. That doesn't happen. You have specialties, but it's not so foreign that you can't transfer your knowledge. And then now we have the additional dimension of internal combustion versus electric versus hybrid and maybe even hydrogen. We've seen a few of those driving around. I don't know if they're commercially available yet. So you get different drivetrains, and that changes the picture a little bit. But still, for the most part, they all have wheels, and they all turn, and they have to brake when you come to red light. And so those mechanics kind of are universal, even if you need a different size wrench for each vehicle. So yeah. I wonder if we're in a similar sort of situation that the big cloud providers, unless Microsoft buys everybody eventually, which I'm sure they'd love to do, we're going to have this splintering, but maybe that's okay.
And I agree that, because I obviously run a practice with a whole bunch of DevOps guys, and that's my argument, right? If there's a specific tool that you're looking for that our engineers need to know, like if they know similar ones, then I'm quite happy with that, because they can pick that up, because they're not that different. If you know the principles, then moving from one to the other is not that hard. And I think that's certainly, I think it comes back to what I said earlier, right? The overarching steps continue to be similar, right? There's there's orchestration, there's automation, there's infrastructure, there's these components you need to pull together. You build some templates. I mean, and infrastructure has now become like code, right? Where it's like, like open source, you pull these different components of the infrastructure together. So it's becoming closer and closer.
Mm-hmm.
That's interesting that you guys are saying that, because on the data science side, I feel like I'm seeing almost the opposite, where there is a really big push to standardize. And so I kind of, I sort of see both sides of the argument where, okay, as long as you know the fundamentals, it's fine, and you can switch pretty easily between frameworks, because I think that's quite often the case. But then on the other side, I am seeing much more of a big push to kind of standardize these different processes and workflows, like how we treat, like a data frame, which is essentially, like an Excel file or a CSV. Or at least that's the data model that you can keep in your head, or how to train, machine learning models, how to test them, how to evaluate the hyperparameters. There's like a huge push towards standardizing all those kind of processes that have, like, I don't even know how many machine learning libraries are out there these days, but like there's a lot. There's a lot. But now, lately you're getting some that are not even new machine learning libraries, just like, we have had enough. We want a standard way to talk to all these libraries so that we can test, across all the different types of models with all the different hyperparameters, which is, some ridiculously large matrix once you get to the end of it, and all that kind of thing. So I don't know. It's interesting, because I'm not really that sure like which direction it's going to go in. Is everybody going to keep pushing for standardization, or is is it going to be like, you need to just kind of adhere to this spec so that the computer can understand your code, so that it's easy for like the IDEs to sort of translate between the different languages? I don't know. I'm not sure.
I don't know either, but I have hope. Because I find it amazing, right? If you look at how big IT is, and how, if you look at it objectively, how immature we are when you think about, how do you even measure whether you're progressing? Like getting an engineer from one organization to the other, these principles that Jonathan and myself talk about are similar, but there's no guarantee that the process looks anywhere similar for them, right? Because you measure completely different things, you have completely different processes. Like it feels like there's a castle on the hill that everyone wants to get to, that we all agree on, which is this kind of hyper automation where you just really define the payload. But we're just completely wandering around this mountain range. It's like, some people are going down this pathway, some of this pathway, and we never really get there, which is kind of fascinating.
Yeah. I'm curious to hear what you think. I think the part of the problem is that we think it's a technical problem, but it's not. It's really a people problem.
Yeah, it's never a technical problem. Like it's always a people problem, almost always.
And the tech only makes it easier. And then we get, but this is no different to why we have this thing here that is like 10,000 times more powerful than what Apollo had to fly to the moon. And still opening Safari browser takes 3 seconds.
Yeah.
Right? Because we're lazy. Like as soon as something gets easier, we become lazy, and then it bloats. Right? And it's like you get new technologies. You now have microservices, and you have moved from your old architecture. You have fully microservices. Fantastic, right? And then because it's so easy to do, you just have incredible amount of redundancies in these services that you then have to manage. And now we're spending all our time dealing with that redundancy. Like you have to continue to exercise. You have to continue to stay healthy, and that is just a bit that we fail. But we are getting better, so slowly.
We are getting better, and it is slow, but I think the the more we get better, this is just what basically what I'm rephrasing, I think, what you just said, or something you alluded to. The more we get better, the more we realize how much better we can get. So that castle on the hill is always getting bigger and fancier and more luxurious and farther away.
Yeah, that's true. That's true. And it gets fancier, right? It's like, oh, and we can can add extra bit here and that extra bit there. And,
I mean, just look at Star Trek. In the '60s, Star Trek was really forward looking. Oh my gosh, such amazing technology they have, and and then in the '80s when they came out the Next Generation, you look back at the '60s, like how ridiculously old does that look? If that's our castle on the hill, it's evolving too, ahead of us. But there are some of the things from the '60s Star Trek that are still way cooler than what we have now. Fast and light travel, transporters. My goodness, they used tapes and they printed out papers. But what the heck?
Yeah. So I mean, when I started this in our company, I was kind of one of the early guys, and before people believed that this would be something real. And I quite honestly put it in my targets that we would just have DevOps adoption everywhere, and then I'm going to go off and do something different. And I've now resigned myself to the fact that I'm probably going to do DevOps for the rest of my career, and then hand it over to my son to run it afterwards. But it's just not going to stop. Like there's always the next technology and the next barrier to break. And we will always have to get better and keep up with those capabilities. I give you another example, and this is, I don't know whether that reflects well, but I used this recently with a client where like, why does this matter? And if you think about it, a few years ago, if you wanted to go live with an enterprise application, you had like, I don't know, a dozen components, and you went live over a long weekend. And a dozen components I can manage in my head. But I can say this is version 1, version 3, version 6, and then I kind of go live with it. Now, if I have hundreds of components and I go live every week, then you can't keep it in your head anymore. That means we needed to create capabilities to manage that complexity, right? And then we get faster again, and we have more components, and we use more open source elements that I need to manage, and we need more infrastructure components that I can ethereal and just come up for a millisecond. But now I have to manage that, right? So you have new capabilities. And then I have to create capabilities to manage that complexity. And then I get new capabilities. And, it's this flywheel.
Bots to manage the bots to manage the bots.
And it's turtles all the way down. But it's because we are dealing with, I mean, we have a world around us that is more powerful, more, it can be more powerful. It can also be really frustrating. And we need to help manage it. I mean, our job, I think it is, in the industry, is to keep up with it, because otherwise we go out of control. There's this beautiful saying that to make a mistake is human, but if you want to create a catastrophe, you need automation, right? And I think that is absolutely true, and I've seen it multiple times. For you to take down a production environment with 300 servers and to do that manually is pretty hard, right? There's a couple of automation scripts. You can do that in seconds, right? So
I think that should be like somebody's villain origin story, like comes up from tech and they brought down thousands of servers accidentally. I'm just waiting for the day. I'm sure it's already happened.
There are three really nice examples, right? There's this guy who built like a cloud-based company that kind of creates development environments, right? And they woke up one morning and basically their whole library and everything was gone in the cloud because they had run a script with a variable in it, and the variable nulled out, and so basically went to the root and deleted it all. His company disappeared overnight because there was no backup, nothing like that. Right, and it was not small, it wasn't huge, but it was like like a couple of $1 million revenue company. Right. Then you see the example of the guy who got into a fight with, I want to say it was GitHub or whatever it was, where he took his little library out with removing the left space. Right, and basically brought the whole internet to breaking. That to the point.
Oh yeah, wasn't that an NPM package or something?
Correct, yeah. Right, and then he basically then agreed to put it back in. Right, but again, like there's a complexity that we can't, and it's not like that you or me can't write this piece of code. It's just we didn't know that it was in so many other things, these transient dependencies that no human can manage. Right, and then there was the example of the Amazon outage where they basically had a whole bunch of things where they're like, okay, I'm going to clean out a bunch of old old data sets, and he basically ran it on the wrong qualifier. And because the pop-up that came up for the engineer was, "Are you sure?" Well, has anyone ever pressed no? Of course you're sure. I mean, you wrote what I think. But again, because it's out of context, right? If it was that, "Are you sure you want to delete 5 quadrillion data sets?" He would have said no, but it just said, "Are you sure?" And so, you know what I mean? Like, these are the things that are outside of our control sphere, and we just need to have the systems that help us. And I find that fascinating. Like, this is like, I'm an optimist, and yet I'm cynical.
Yeah. Good combination, I think.
Yeah, I think it's it's all a distance metric. It's like how far you have to go to get to the castle is also how far you have to fall into the underworld. I think it's just it's a vector going in either direction. You gotta hope that it's going in the right direction.
And I think part of all the kind of coaches and transformation guys and whatnot, I think part of the job is to make it a somewhat enjoyable journey. Like, it can't be this kind of death march. It has to be something where people, enjoy the landscape and get some pleasure from making the next mark and the next step forward and so forth, right?
I think in general, tech attracts people who have what I call like to learn new things disease, because the people who don't have that disease tend to find something else that makes them, less frustrated with the world than the library has had another, version upgrade and all these syntaxes don't change, right?
So and this tells you why I'm in this industry. So when I was a teenager, I actually want to become a tax advisor. It's a very weird kind of dream job to have. But I had this idea that, I make money and then I also learn how to optimize, how to get the minimum amount back to the state. Anyway, I did an intern job in an IT department. And then one day I came home to my dad and said, like, "I'm going to go into IT." And he's like, "What has changed, Mirco? Like, why do you want to do that?" I'm like, I've been now in this department for a week, and I realized what they do. They build a product, they roll it out, and then later on they get paid to fix it. And then they build the next version, and they get paid to do the next version. And there's no end to it. It's like, you will never be out of a job. I'm like, I find that genius. Very insightful for a 16-year-old.
Yeah, it's like trying to explain paperwork to kids. I'm doing this paperwork so I can give it to somebody else, and then they give me back more paperwork, and so on and so forth. Yeah, you're right. I hadn't thought of it like that. It's the job that never ends, because you're constantly creating yourself new jobs.
Yeah. It's probably the same for most of technologies these days, right? Like, it's not like the TVs and washing machines and so forth last for a generation. But certainly in IT, it's extreme.
No, I'm convinced every appliance now has a 3-year ticking time bomb inside of it, where it just explodes. Like my blender, every 3 years on the dot. My great uncle had the same blender for 30 years, I think. 30 years. Yeah. All right. That's a complaint for another time, but I'm very annoyed that my blender is currently not working.
So I've heard that I haven't bought it yet, but I have the same experience. And I've been told, my wife is Sri Lankan, that in Sri Lanka they still sell some of the kind of old school stuff, and that lasts 10, 15 years. So it's on the list for the next trip to just bring back a blender.
It's a good idea. Save yourself frustration.
But it's amazing. I mean, think about cars, right? Like, I remember my older brother fixing a car, like an old car, and just repairing it. And now, I drive a Tesla. What am I going to do with that thing? Like, if there's something broken,
yeah.
There's nothing to fix here. And that's actually, again, a good analogy, right? We can stay with your car analogy, Jonathan, because it's the same thing. Like, in the old days, you could probably fix a whole bunch of stuff yourself. Right? And you had a much broader range of what you can do. Think about when I had my first PC, the config sys and auto-exec button and whatnot that you kind of tweaked to make the memory allocation better. Like, you wouldn't try to do any of that stuff now, because it's just outside of your all of your area of access.
Yeah, I used to. Yeah, of course, I played with config sys, and then I switched to Linux, and I compiled my own kernel, and I would go through and disable all the modules I didn't want, and think, read up on all the, I could set this number to 128 or 256. What does that mean? I'd look all that up. I haven't compiled a kernel. I think last time was about 3 years ago, when I was trying to use an HDMI capture card that required a specific kernel patch. And then I stopped using that. So yeah, I don't do that stuff anymore. I don't need to.
Yeah. Well, and there's probably way too much now in there for you to actually understand it all, right? Like, it's not like the 15 things that you could worry about. It's like it's 5,000, and it means like where do we even start? So you need to use the abstractions. You have no choice.
Yep.
But it's yeah. I mean, this is fascinating. This is a really great conversation. This is much more deeper than I expected.
No, it's always fun to have these chats.
Yeah, I think one of the really fun examples of that is looking at like package managers, just even in the last like 5 or 6 years, and how much more complex they have all become, and how many of them have, like bots to manage the bots to manage the bots. Like you can really go and dig into these things because a lot of them are online. So for example, I used to do a lot of work with the Conda package manager. I don't know how many layers of abstraction that thing has anymore, but it's a lot. It's a lot. And then it was too slow, so then somebody rewrote it in like, C or C++, and then somebody rewrote the rewrite, and like it's getting out of control. It's wild.
Yeah, I mean, I've read the one of the security reports, and what it said, like, it's all about transient dependencies now, because it's just it very quickly, that tree becomes very quickly so large that you can't control it anymore, and so you have to kind of figure out like where can we even interface with this stuff anymore, which is kind of scary to some degree. And then we get to we're doing DevOps weeks at the moment here in our company, in like a week-long conference, and we have lots of people presenting. There was quite a few machine learning conversations, and just the difficulty of controlling that, right? Because if you train something, you're now training not on like individual data sets, like it's the gigabytes of data that you basically have to version control, because that is what created that model, and you have multiple of these experiments running in parallel, and it's outside of anything that you can control in, where you just have to assume that, the abstraction is good enough.
Yeah, reproducible research has been struggling with the same problem for, I suppose, as long as there has been research. I remember Nature came out with a paper. Oh, I don't know. It was a while ago, but it was about how like nothing was reproducible, and it was quite a scandal when it happened. But yeah, specifically because of what you're talking about, you also have to version control the data, and the data is very large, and you get into this, and so then all of these new types of problems. So you have to version the data, version the software, version any compilation changes. Specifically with a lot of the machine learning libraries, it's a whole lot more things than anybody could ever possibly manage in their head.
Yeah, and then we come back to the ghost in the machine, right? Like you're doing the same thing, and it just turns out differently because there's one variable somewhere in this that you didn't control. Or you're getting statistics now, right? Because with machine learning, you end up. We're doing demos, right, to clients around Gen I created code and Copilot and so forth, and I can't predict the bloody outcome. Like I just can't, right? And then you just have to be comfortable with the variability in this.
Yeah.
Well, yes and no. So for a lot of, specifically with the machine learning stuff, you're supposed to have some external way to validate that does not rely on a computer, right? Like in biotech, a lot of times you're testing for a compound that has some medicinal activity, and then you get a computer to generate something that looks similar, and then you go generate that thing that was generated, and then you go test it in the lab. So there's some feedback loop in there somewhere that should be real. When you exist too much in software, though, I think maybe it does get a little bit, I don't know, it's like too meta or something. There's too many layers of abstraction. Like you said, it is a ghost in the machine. Who even knows anymore?
I remember Ghost in the Machine as long as I go back. Like when my first engineering project, and for whatever reason, the answer to the problem was to allocate A to A, and then the problem was then solved itself somehow. Never knew why, but those things used to happen, and I'm sure it still happens.
Is there anything else we should touch on before we start to wrap up?
I think I've covered my ground, to be honest. Like this is kind of the stuff that I'm fascinated by. The only thing is probably the rallying cry that we really need to focus on solving those problems and not get too excited about those buzzwords. We didn't talk too much about this, but I find this incredibly frustrating that, now everything needs to be SRE and everything needs to be platform engineering, everything needs to be this and that. And I find this obsession a bit, I think Agile has it worse because they have these kind of really strong fractions where, the SAFe framework versus the Scrum framework versus whatever. And to the point that they can't talk to each other. If I'm the principal of one, then you can't be the principal of the other. But I'm really, in our community, we need to make sure that that doesn't happen, because one of the good things for us is that we never had a definition and that we never kind of had these hard barriers.
Mm-hmm.
And I think we need to continue to just subscribe to improving the situation with whatever we have available to us. And every new idea, every new tool is just another tool in the toolkit. And you can choose to use it or not. And that's up to you.
Shall we go to picks then? Do you have one, Jillian? You want to start us off?
I do. So I have been messing around with the AI tools lately, specifically GitHub Copilot and Tab 9, which are both plugins or extensions you install into your IDE. I mostly use PyCharm and CLion, which is like the C++ version of PyCharm. And I'm pretty happy with the different tools now. They're pretty cool. They do a pretty good job. Sometimes they give me total nonsense. Like today, I was like, oh, that's neat. I didn't realize that was a function that existed. It turns out it was not a function that actually existed. And so then, that threw me an error. So GitHub Copilot, I'm not sure what happened there. I'm pretty excited for the voice activation that's supposed to be coming along with GitHub Pilot. I will totally pay for that if somebody is here who, has the inside scoop on GitHub and can get me added from the waiting list to the actual product. I would very much appreciate it. So those were really neat, and it's actually gotten me kind of to learn, some new frameworks. And I've been a bit, I don't know if I'm getting too old for this or what, but where I'm like, oh, I don't want to learn any of these new frameworks that crazy kids are using these days. But now, since it's so much easier with the AI autocomplete tools and things like that, I'm getting into the PyArrow C++ library, which has really good performance. So that's been fun. And then the other one that I have is AWS Omics, which is like their kind of platform for doing genomics research. Recently released these workflows called Ready to Run, which are these kind of like pre-configured analysis workflows for different types of genomics and a lot of chemical informatics engineering. And I think it relates really well to what we've been talking about on the show with this idea of like continuous improvement and the ghost in the machine and all this kind of thing, because to get a workflow that you're treating like software, you have to have so many different moving pieces. You have to have data itself that is under version control so that you know like what to expect in the data. Some of these data platforms aren't deterministic. So then how do you test to see if some result is within an acceptable range or not? How do you get the results? Where do you store the data? All these different kind of ideas that people have been struggling with, for as long as there's been research, I guess. There's, now kind of some really interesting answers, I think, for the first time, at least that I've been working in research, that these different pieces have come together. Because it used to be, okay, we can have these workflows, but we just don't have the storage to store enough, variations of the data that we can really test this thing on demand. And now they are able to be tested on demand. And then specifically for the more self-serving, side of myself, I do a lot of this kind of analysis optimization, and I work with a lot of startups that they want to create an analysis workflow and then kind of like license it, or like rent it out to collaborators and things like that. So having yet another platform that allows for that is pretty exciting for me personally. So that's it. Those are my picks. What about you guys?
I have one pick this week. It's an audio book I'm reading. I'm sure the paper book is just as good if you prefer that. It's called Stealing the Corner Office, the winning career strategies they'll never teach you in business school. And the author talks about, he gives several anecdotes from his own life and life of people he knows, but it basically talks about the problem, the reality that we all have experienced incompetent managers and the paradox of how do incompetent people become managers, and why is their career always advancing when those of us who are trying hard and doing the right things are being overlooked for promotions and so on. So he takes the approach of what can we learn from these people? What are they doing right that we can copy without also becoming incompetent to advance our career? So that's the premise of the book. I'm about halfway through it, and so far it's really good. So that's my recommendation for the week.
Do you know the answer yet? Is it people skill? So you have to read the whole book.
There's I think he says 7 different techniques or traits that he recommends borrowing from these people. So
that sounds
It's not
interesting.
just a single answer. It's a little bit more complicated than that.
Never is.
Yeah.
All right. Well, I'll choose two picks. One is a book, New Dark Age, from James Bridle, which is very much related to what we've been talking about, to be honest. It makes the argument that we're getting into a new dark age. And the definition of a dark age, in his view, is that we're using technologies that we don't understand. And that we can't, we can't get under the covers to figure out how the mechanism works. Obviously, in the original Dark Ages, there was a lot of those kind of things that, started working for us, being in chemistry and physics, whatever. And then it took us quite a while to get to understand why. And now we're getting into this world with AI and everything else, where the individual can't control it anymore and doesn't understand how it works. And that means, like we are at the mercy of technology. So it's very interesting the way that he describes this. He has this fantastic example of YouTube where you have AIs creating content and AI consuming content, and in between, companies spend their marketing money, people creating videos only being consumed by AI, and how do we control this? So it's a very, very fascinating topic. He has also, I think, a couple of TED Talks if you want to just get the 12-minute version. But I find it incredibly fascinating. And then my second pick is a bit self-serving, which is my own book. So if you like kind of what I've been talking about, I have a book called DevOps for the Modern Enterprise that goes a little bit into this kind of thought process of how do you deal with it in a large organization. And I give away pretty much all my consulting practices in the book and basically say, here's what you can do at home and something you can try at home.
Awesome. Great. And how can people, if people are interested in reaching out to you, are you on social media? How can they contact you?
Yeah. So obviously LinkedIn, Mirco Herring will work. I have a blog called Not a Factory Anymore, which takes this kind of principle that we shouldn't call software factories and stuff like that. It's a more artisan practice. And then on Twitter, Mirco Herring as well.
Great. Thanks, Mirco, for coming on. It's been a pleasure. It's fun topics we've been discussing. So thanks for coming on, and hope to see you on here again in the future, perhaps.
Yeah,
this was absolutely fascinating. So I will be very happy to come back and do another round of fun.
Thanks, everyone, for listening. We'll talk at you again in about a week. See you then.